metallic bonding, right? So what we do, we draw the cations in a rigid lattice. So draw at least 3 layers of cations. And then draw the delocalized electrons. But it's important to it's important to label them. These are the cations. You can correct your answers now. Cations and delocalized electrons. Right?
So can you say free electrons as well?
Sorry?
So can you say free electrons as well?
Yeah, free electrons possible. Right? Okay.
Then also
Second.
the cations, positive ions.
Okay.
So can you also say positive ions for the cations?
Correct. Okay. Use ideas about the structure of metals to explain why metals are okay. Yeah, use ideas about the structure of metals to explain metals are malleable because the cation layers slide over each other. Without breaking double bonds. Sorry, without breaking the metallic bond. Without breaking the metallic bonds. Okay, so how many marks given for this question? Only 1 mark. So this is more than enough. The cation layers slide over each other will give the 1 mark. But if you are going to write the full answer, it's the cation layers slide over each other without breaking the metallic bonds, right? Is much better answer. And why it's a good conductor of electricity? That is because the electrons are delocalized, so they can carry the charge across the structure, right? You can simply say delocalized electrons. You can use Z or S, it depends on American or English pronouncing, doesn't matter. Delocalized electrons carry the charge across the barrier, across the metal. පුතා අත උස්සන් ඉන්නකො ප්‍රශ්නයක් තියෙනවා නම් අත උස්සන් ඉන්න. දැන් මම පන්තිය පටන් ගන්නකොට මම එක්ස්ප්ලেইন කරා මේක රිවිෂන් ක්ලාස් එක. Don't jump right into the discussion. ඒක කරගෙන යන්න බැරි වෙනවා එතකොට. මේක ඉවරයක් කරන්න බැරි වෙනවා. හරි. Delocalized electrons carry the charge across the metal. Also, you can type and leave the question to me. And then the second part B suggests why the silicon dioxide doesn't conduct electricity. So silicon dioxide is giant covalent. This is giant covalent. As a result of that, you usually don't have like moving ions or delocalized electrons unless it is what you call graphite, right? That's one of the exceptions in this case, right? So what you have to simply write suggests why silicon dioxide doesn't conduct electricity. That because there are no delocalized electrons. There are no delocalized electrons. Because you have to relate that into graphite and say, because graphite can do it, no metals can do it. When it is a solid, especially talking about covalent substances, talk about the delocalized electrons. But just in case, now this is for 1 mark, right? But if they ask like why is that, then you can say silicon has 4 electrons in the last shell. And all of them are used in bonding. Right? Next. It is hard. So it's a giant covalent lattice, right? So when they say hard, one of the easiest answer you can say when it is giant covalent substance, there are many strong covalent bonds. Many strong covalent bonds. Many strong covalent bonds. Many strong covalent bonds. So it's hard, right? There are many strong. Right? But what are we going to do? We are going to learn how to do it, by the way. This is very simple one, don't worry. There is something called molecular formula. In the molecular formula, what we do, we write the exact number of the particular atoms you have there, right? So when you count this, you have 1, 2, 3, 4, 5, 6. In this formula, there are 6 palladium atoms, right? And when you count the number of chlorine atoms, there are 12 chlorine atoms. So basically, the molecular formula is this, right? But the empirical formula means the simplest ratio of them. Then it becomes palladium PdCl2, right? Next one. Sodium chloride has ionic structure. Explain why sodium chloride conducts when molten but doesn't conduct electricity when it in the solid state. Because in the solid state, these ions are not moving because they are at fixed positions of they are at the fixed position of the lattice structure. So they vibrate only. They can't like move, right? But when they are molten, the ions can move, right? The ions can move. Okay, so what do you write? Explain why sodium chloride conducts electricity when molten but doesn't conduct electricity when solid. In molten form, ions can move. In molten form, ions can move and carry the charge. But in solid form, ions are at fixed positions. Fixed positions. All right. Okay, so next one. Dot and cross diagrams for Cl2O, right? So how we are going to do it? Let me do it here. When you take the chlorine atom, it has 7 electrons in the last shell. So it needs 1 electron. Let's have a look at oxygen. It has 6 electrons in the last shell. So it needs 2 electrons. So you decide this is covalent bonding. So you need 2 chlorine atoms for 1 oxygen. Anyway, everything is given in the question, right? So you can see too. So you decide to have 2 chlorine atoms for 1 oxygen atom. And since chlorine is sharing 1 electron, oxygen is also sharing 1 electron. So it goes like this. And don't forget to put the rest of the electrons of these atoms, right? So, and then oxygen also had 6 electrons. We have to put the rest of the 4 electrons. So this is your chlorine, Cl2O molecule. Explain using ideas about the structure of bonding why Cl2O has a low melting point, right? Okay, the reason is, this is first thing you must write here. This is a simple molecular structure. Simple molecular structure. Right? This is simple molecular structure. So the molecules have weak forces of attraction. Molecules have weak forces of attraction. Right? So you need less energy to what? Overcome these weak forces of attractions. Right? So you can include that as well. So simple molecular structure, molecules have weak forces of attractions, so less energy is needed. Less energy is needed. So how do you get the marks here? You must mention this molecule word here, right? If you say molecules are there and there are weak forces of attractions, you get all 2 marks. Also, you can say simple molecular structures, therefore less energy to overcome the attractions, 2 marks, right? So if you can write all these 3 points, you definitely get the 2 marks without any issue, right? Now this is either these 2 or the simple molecular structure with weak attractions, right? Whatever the way. So what you have to focus is less energy is needed is not the main point. Just write in that you don't get the mark, right? Just saying less energy is needed is not enough, right? You must say right, you must say that simple molecular structure, the presence of molecules. Okay, so draw diagrams to show electronic structure of the charges of both ions present in potassium oxide, right? Okay, so first of all, you have to understand what is potassium and oxygen, what are potassium and oxygen atoms valencies. Draw the diagram to show the electronic structure. So when they ask electronic structure, they basically require you to draw all the electron shells. For example, potassium, right? Potassium will have 2, 8, 8, 2, 8, 8, 1 structure, right? So this is basically potassium because it's in the, it has 2, 8, 8, 1. It has like 19 electrons, right? Agreed? And what will happen when it gives out the electron? So first of all, you have to understand potassium is metal, oxygen is a non-metal. So these 2 are going to form ionic bond. Therefore, you get the potassium ion and the oxide ion, right? Okay, so then when we remove the last electron here, we remove the last electron and it becomes potassium ion, right? And then oxide, they don't ask you to draw like with those numbers, they just want you to draw the ion and the charge, right? And they ask electronic structure charges both ions present in oxide. Now oxygen needs 2, right? It has 2 6 in the 2 6 in the normal electron configuration. But once it takes 2 electrons from potassium, right? You need to have two potassium atoms to bind. That's a different story, right? It must take two electrons. So then it becomes the oxide ion, right? So you must have put 2 in front of potassium. That's all right. It is correct anyway, right? So they want you to draw this potassium ion with the electronic structure of 288 and oxide ion with the electronic structure of 28, right? So that's the answer. So how the marks allocated? Simply one ion with the charge, it's going to be 1 mark. Potassium ion 1 mark, oxide ion 1 mark. Right. Chlorine forms another oxide called Cl2O7. 1 mole of this reacts with 1 mole of water to make. Don't worry, that part is not for you. Right? That part is not for you. You don't need to like 2 questions. Okay. So here you have molecules. So these molecules are just stacked together. You know that since they are like isolated molecules, between two molecules there are no like strong bonds. You have, whether it's solid or not, you have only weak attractions. Simple molecular means in weak intermolecular attractions, right? Weak intermolecular attractions. So explain why solid iodine doesn't conduct electricity. That is because, so it's a covalent substance, right? Since it's a covalent substance, it is not going to have like delocalized electrons. No need to talk about the ions, because covalent substances, you know covalent in molecules. So then basically you have to talk about the delocalized electrons. So you basically say no delocalized electrons. No delocalized electrons. No delocalized electrons. Right? And when heated, solid iodine turns directly into iodine gas, right? Use the kinetic particle theory to explain this change. Now, if a substance goes from solid to gas, you know, gases do not have intermolecular attractions or very weak attractions, right? Therefore, you have to quickly understand when it is heated, in iodine, all the attractions between the iodine are overcome. Now iodine molecules are completely free to move. That's what you have to say, right? So the uh, heat energy is used to overcome all intermolecular attractions, or just say intermolecular, or overcome intermolecular attractions, so that iodine molecules are completely free to move. Completely free to move. Then it is a gas, right? Completely free to move. Right? Then it is a gas. Right? So draw dot and cross diagram between iodine molecules. Such an easy one, right? See, they show only the outer shell electron. Right? So iodine, you have only 7 electrons in the last shell because it's in the halogen group 7. Last shell has only 7 electrons. So each iodine atom needs 1 electron. So then the fair share policy, you share 1, I share 1, right? So what you get? You get iodine sharing 1 electron each. Get iodine sharing 1 electron each. So you get iodine, and this is I2. All right. Okay. Right. So let's go to the question number 4. Question number 4, you have magnesium electron configuration, protons, number of neutrons. So this is so easy because magnesium number of protons will be 12. neutrons will be 24 minus 12, which is 12. You must write 12 rather than like just the working. And the electron configuration is not 282 because it has given out 2 electrons. Now it's 28. Initially it was 282. Now it's 28. Right? මට confirm කරපු ළමයින්ගෙන් කිහිප දෙනෙක්ව විතරයි මට පේන්නේ මේ videos වල. අනිත් අයව මම දානවා මේ meeting එකෙන් එළියට. හරි? Right, if the video is not on, I will I'm going to remove you from the video meeting, right? Okay, so in oxygen, you have 8 protons, number of neutrons will be 8, and it's originally it has 2-6 electron configuration, and then it's going to have 2-8, right? It's going to have 2-8 electron. Okay, describe how magnesium atom and oxygen atom form magnesium ion and oxide ion, right? So magnesium atom is going to, magnesium atom had 2-8-2 configuration, oxygen atom had 2-6 configuration. So the 2 electrons are given from magnesium to oxygen, right? So you have to say magnesium removes 2 electrons, and oxygen atom gains 2 electrons. Right. So it's just 1 mark. Right. You have to include that explanation. Explain in terms of structure and bonding why magnesium oxide has very high melting point. Right. The reason is, first of all, you must say it forms giant ionic structure. Giant ionic structure. Right? This is 1 mark. Now, any of the 2 points that I mentioned will score 2 marks. Okay? Or you can say there are strong electrostatic attractions. Strong electrostatic attractions between magnesium ions and oxide ions, or oppositely charged ions, 1 mark. But always remember the mark allocated for this, a lot of heat is needed. A lot of heat is needed. It doesn't make any sense. Lot of heat energy is needed. It doesn't make any sense if you don't mention that the bonds are strong, very strong, right? A lot of heat energy is needed to overcome ionic bonds, strong ionic bonds, right? So that's also 1 mark. So any of these 2 points out of these 2 can score, right? Even you have written in a very short form, a lot of heat energy for ionic bonds. So a lot of heat energy for strong ionic bonds, right? Needed, right? But just ionic bonds doesn't score both to both marks. You must say either it's a giant ionic structure or there are strong electrostatic attraction between the ions. Right. So let me give you the screenshot. 2 solids do not conduct electricity because you have to say the ions are at fixed positions, or ions are not allowed to move, right? So anything mentioning that ions cannot move, right, that will score 1 mark, right? Next one, explain why magnesium oxide has very high melting point. The same answer. right? Giant ionic structure, giant ionic lattice. So lot of energy is needed. Lot of energy is needed. Energy is needed to overcome strong ionic bonds. Right? Actually, it's just 1 mark. So therefore, even you say it is a giant lattice structure, then giant ionic lattice, you will get the mark. Right? Suggests why melting point of magnesium oxide is much higher than that of sodium chloride. Right? Okay. This is because now this is a very tricky question. Why am I saying both of them are giant ionic lattice, right? Both of them are giant ionic lattice. So then why only magnesium oxide has much greater value than sodium chloride? Because magnesium 2 plus and O2 minus have greater charge, a greater charge, a greater charge, right? So the ionic bond is stronger. Ionic bonds are stronger. Ionic bonds are stronger. Right? The ionic bonds are stronger. Question. Name the type of strong bond shown in the diagram. Right? They ask only the bond, right? They only ask the bond. So the bond is covalent. Right? No need to write what? Whether it's giant covalent, simple molecular structure, or anything like that. Explain why both diamond and graphite have very high melting point. So this carries 2 marks because the both questions have 3 marks altogether. This is going to carry this is going to carry 2 marks, right? So explain why both diamond and graphite have very high melting point. You are going to say either these two statements. One, you can say they form giant covalent structure, right? Giant covalent structure. You have to say this, or you can say there are many strong covalent bonds. Many strong covalent bonds. Many strong covalent bonds. Many strong covalent bonds, right? And then it should be followed by saying that a lot of energy is needed to overcome those strong bonds of the lattice, right? But I'm emphasizing again, this lot of energy story has a meaning when you connect that into the covalent structure only. Lot of energy is needed to overcome those many strong covalent bonds of the giant covalent structure. Such is why the melting point of graphite is lower than that of diamond. You know that there are 2 answers actually you can give. One is the graphite has less number of covalent bonds than diamond, right? Each carbon atom is bonded to 3 other, whereas in diamond you have 4 carbon atoms attached to each carbon atom. That's one answer you can give. Also, you can say diamond has some weak force of attractions between the layers. So you can mention that as well. So the answer could be, you can say in graphite graphite has 3 bonds, 3 bonds for each carbon atom. For each carbon atom. And diamond has, or whereas diamond has 4. Diamond has 4. So that makes sense, right? So diamond has more bonds. Also, you can write either. You can say graphite has graphite has delocalized electrons. Or you can say not delocalized electrons, sorry, you can say graphite has weak force of attractions between the layers. Diamond doesn't. Weak forces of attractions between the layers. Between the layers. Right? Right. Okay, compare the electric conductivity of diamond and graphite. Explain your answer. No, it's 2 marks, right? For 2 marks, let me write the answer C here. In this case, I will give you kind of an elaborated answer, right? Whatever it is, you have to refer to the delocalized electrons because it's a covalent structure, right? So you are going to say graphite has delocalized electrons. Delocalized electrons which can carry the charge. Which can carry the charge. Which can carry the charge. Right? That's 1 mark. And you say like the opposite argument. You can say diamond doesn't have delocalized electrons. Doesn't have delocalized electrons. Right? So technically this question, according to what they have given, you should get full marks for these two. But let's say this question is about 3 or 4 marks. Then further elaboration on why graphite can conduct electricity or why it has like what you call delocalized electrons or not has to be explained. Right now, just for this particular question, this answer is more than enough, right? This answer is more than enough. But I'm just giving you some value additions. If the question is about like 3 or 4 marks, you're going to say that in graphite, each carbon atom has 3 bonds. So it has 1 electron free. 1 electron free. So then throughout the structure there are free electrons. Opposite argument here is diamond doesn't have delocalized electrons because, right, all four electrons in carbon atoms. Now when we say all 4 electrons, we are referring to the valence shell electrons. All 4 electrons in carbon atom are used in bonds, used for bonding, for bonds. Right? So that's elaboration on this, right? Okay, so that's what you have to give. Whatever the bonding question is there, the first thing that you need to do is just check the elements given to you is a metal or a non-metal. That's the first thing you have to do. Because depending on metal or non-metals, you are going to decide the type of bonding. Right? So that's the very first thing in the bonding lesson. So magnesium is a metal, so it's going to remove electrons. So whenever you follow the basics, you can find the answers very clearly. Non-metals gain electrons, right? And then check the number of electrons, right? Number of electrons by writing the electron configuration. Now we did it once, but I'm just like emphasizing it again, right? So then let's check the answers here. By giving one pair of electrons to oxygen atom, sounds pretty correct, right? Because it's giving, but let's cut off the others by using some obvious mistakes. Now, for example, here they say sharing. When they say sharing is for covalent bonds, right? It's for covalent bonds, and these two are metals and non-metals. They must form ionic bonds. That's how you remove the BCD. Therefore, the answer is A, right? Which diagram represents the structure of the metal sodium, right? Metal sodium is going to be, metallic structure with the lattice structure of cations, and the electrons are delocalized, right? So then it should be definitely C, and this is graphite. Now you can identify this is graphite, and this is diamond, and this is sodium chloride like ionic compound, right? So what you basically have to understand, uh, when it is like sodium chloride, right, or ionic substance, they will give you different examples, different compounds, right? And you never have to remember these compounds separately. For example, what are the properties of sodium chloride? What are the properties of sodium oxide? What are the properties of magnesium chloride? What are the properties of magnesium oxide? That is not possible, right? It's impossible for us to remember these properties separately. But what you need to do when they say sodium chloride, magnesium chloride, sodium oxide, they are ionic. So if they are ionic, we are going to take the properties of ionic compounds, right? That's what we are going to do, right? Okay, I've just given an idea like how to handle the questions coming in the future, right? Let's move on. So then it's going to be metal, and the third one, which diagram represents the structure of sand. That's so easy. Silicon dioxide, you can quickly identify it's a giant covalent structure. The answer is 3. The picture of this. Sodium ion, chloride ion, sodium ion, chloride ion, right? So always have a mental picture of substances. Then only you will be, successfully doing science or chemistry. So this is the solid structure of sodium chloride. And when you heat it, right, just the ions are now bit of release to move, right? When you heat it and molten, now the ions are not very tightly packed, they can move around, right? So that's the idea, right? And sodium chloride, you already have ions, you don't have atoms. So then don't tell heating will make ions. There is nothing to make here. They are already ions. So then remember that point. So covalent bonds, there are no covalent bonds in sodium chloride. It is an ionic compound, so it's wrong, right? Electrons are released from the atoms. No, it's nonsense. They are already, electrons have been transferred, ions have been made. See, electrostatic attractions between ions overcome, right? That sounds very correct, because what you have here, ionic bonds. Ionic bonds are strong electrostatic attractions. So what you have here, strong electrostatic attractions. Strong electrostatic attractions. Right, I'm sorry about the background noise, Lamai. I don't have the control over them. Right, I can't go and say the houses council lage wala dene ka natara karna mara pantiya karanna oni kela. I can't tell that. You can understand that, right? Okay, so we'll focus on this and do, right? So then this is all right, and then molecules are separated into ions. Wrong, no molecules in ionic compounds. No molecules. No molecules. Okay. No molecules in ionic compounds. In ionic compounds. Right. Therefore, the answer is C. Right. Okay, question number 5 we have done in the class, right? So which set of data shows that graphite conducts electricity S and then T and can be lubricant? So the answer is B. Let's go to question number 6. Rubidium is in group 1 and bromine is in group 7. Find rubidium. Now we can't draw the electron configuration of rubidium because it has many electrons, right? But rubidium, we can surely say there is one electron in the last shell, right? And when it comes to bromine, and it is also quite difficult one to write the electron configuration, but it's all right, we don't need it because we just want to know how many electrons are in the last shell, because this is in group 1, this is in group 7, so then they are going to be like that, right? So how is a compound formed between rubidium and bromine? Each atom bromine shares electron shares කිව්ව ගමන් වැරදි ළමයි. ඇයි? මං කිව්වනේ whenever there is a bonding question, this is a metal, this is a non-metal. Ionic compound. එහෙනම් මේක ionic. No sharing, right? No sharing. They are going to form ions. Rubidium is going to give electrons fully, transferring electrons, right? Each atom of bromine shares. Shares කිව්ව ගමන් වැරදි. Right? Each atom of bromine gives an electron to atom of rubidium. No, the other way around. Bromine is a non-metal. It is going to get the electron. Right? Each atom of bromine receives an electron from the atom of rubidium. Then the answer is D. Right? Okay. So here we each is carbon atom covalently bonded only to 3 carbon atoms. Right? Carbon dioxide. The carbon oxygen double bond is there, the other side. Right? So it is attached only for 2 atoms. Diamond, you can remember each carbon atom is bonded to 4 other carbon atoms. And graphite only, the answer, it has 3 bonds, right? Methane, if you take methane, methane has like 4 hydrogens. Don't ask, okay. So if you didn't know methane, now get to know the CH4 is called methane. Right? Okay. Suppose you didn't know methane, that's all right, that's fine. But you know graphite is the answer, even though you don't know methane, right? Graphite is the answer, right? In which pair of substances that does each have giant molecular structure, right? So this is going to be graphite. Substances does each have giant molecular structure. So it's going to be diamond and silica, right? There is no doubt, that's the easy one, right? But for your further reference, let me say iodine is simple molecular, right? Iodine is simple molecular. SM can is simple molecular. Methane is, we just learned it's a gas and it's simple molecular. And methane again, okay. So silica, we all know it's sand. Okay, metals have positive ions in sea of electrons, right? Metals have positive ions of sea of electrons, that's correct. Which metal atom provides most electron to sea? Look at the valency, right? A valency of calcium 2, magnesium 2, sodium 1, aluminium 3. Therefore, the answer is A, right? Then, which substance has giant molecular structure at room temperature? So that is straightforward one. The answer is going to be B. This molten sodium chloride conduct electricity, right? Again, whatever the bonding question given, metal and non-metal. Now, this is something you know, but I'm always writing for you to make sure that you know what you are doing. Therefore, you decide it's ionic. Ionic now refer to ions. That's the pathway. That's the mental pathway of thinking, right? An electron, molten sodium chloride conducts electricity. There is nothing to do with electron transfer. It happened already, right? Sodium ions are weakly attracted to the chloride ions. Wrong, right? So in wait. That's kind of okay because the ions have to move around. So then weakly attracted is kind of okay. That's a question mark. We'll keep a question mark there. The electrons in the sodium chloride are free to move. Wrong, it's not electrons. Don't refer to electrons. So here are the golden rules, right? Here are the golden rules. Don't refer to electrons in ionic compounds. Electrons in ionic compounds. I mean ionic compounds when you are explaining the electric conductivity, right? When you are explaining the conductivity, electric conductivity. Don't go to that. Okay, sodium ions and chloride ions are free to move. That makes it more accurate. They are free to move. That's why they can conduct electricity, right? So that's why I said that weakly attracted things. It is not very like accurate, right? So the answer when it comes to conductivity of ionic compound sodium, the ions are free to move. It doesn't mean that they are entirely like free, but they are somewhat free to move, so then they can carry the charge. Okay, which compound has both ionic and covalent characters? Hari, make a ඕගොල්ලන්ට answers ලියන්න අමාරුයි ළමයි. Because you don't know formula yet, right? Complete formula structure you haven't learned. We'll be learning formula equations next term. But I'm going to give you some idea about it, right? Anyway, this ethyl ethanoate thing completely out of your knowledge. These are MCQ questions. No? So they are coming from both grades, grade 10 and 9, right? But sodium chloride, you know it, right? Entirely ionic. No doubt, no, it's entirely ionic. Carbon dioxide, you know that non-metals, two non-metals, entirely covalent. Right, so you may be wondering, are you the answer? So don't worry about the ones that you don't know. Let's look at the other one, ammonium chloride. Ammonium chloride. Ammonium chloride is going to be NH4Cl, right? The only issue is you didn't know about it. If you knew it, you could have answered this. So, okay. Here is a very rare occasion. Listen to me very carefully. Very rare occasion. So this is what? This is why the revision discussions are quite handful in exams. This is ionic. But do you see it is violating one of our main rules? Ionic, to have ionic, you need a metal and non-metal, right? But here there is no metal. This is a very rare case. This is an ionic compound, ammonium, positive ion, right? And chloride, Cl minus, negative ion, right? And this ammonium ion, inside ammonium ion, it is nitrogen and hydrogen. And these two are bonded with covalent, right? Bonds. So this is the compound which has ionic bonds as well as covalent bonds. You have ionic bond between ammonium and chloride ion and covalent between nitrogen and hydrogen atoms, right? Okay, Mithila, right? You can leave. හැබැයි ඉතින් ඒ වගේ වෙලාවක ක්ලාස් දෙකටම ෆෙයා වෙන විදියට ඕගොල්ලෝ ඒවා ඩිසයිඩ් කරගන්න. You are losing half an hour from me, but you don't lose any time from the biology class, right? So that's unfair. You know, we are making it to 10:45. Araka Jurna Mari 10:45. There are 15 minutes, 15 minutes.
Okay, fine. Okay, fine.
No, Mithika, no, I'm just kidding. You can go, you can watch this. This is a revision video, no, so you can watch it and check it later, right? Okay. I'll try to upload it today itself in the YouTube and give you the link, right? Okay. Next one. Okay, bye. Good luck. And let me give you one more example. Now you learn sodium carbonate. You learn calcium. You might have heard about sodium carbonate, calcium carbonate in your grade 8, right? So definitely it's going to be sodium ion and carbonate ion. You don't know about this carbonate ion, you'll be learning in detail next lesson, right? Calcium 2 plus ion and carbonate ion, right? So this is ionic, no doubt. But inside carbonate, it's carbon and oxygen, right? So these two are non-metals, therefore you have covalent bonds. So here are some more examples where you have both ionic and covalent bond in the same substance, right? Okay. How many electrons are shared in the methane molecules? How many electrons? Okay. So let's let's draw the methane molecule. As I told you, it has like 4 hydrogen atoms and with 1 carbon atom. So 4 hydrogen atoms means each hydrogen atom sharing 1 electron, and you are going to have like 8 electrons. So then the answer is D. The answer is D, right? Okay.
Excuse me,
And
sir. Excuse me, sir.
yeah,
Sir, can you teach
Sir,
me
what
that
is
part
the
again?
answer for 12th one?
a 12th one answer is A, right?
Okay, sir.
Okay. Methane molecule, you have 4 bonds. Each bond has 2 electrons. Altogether, there are 8 electrons. Right? There is
Okay.
nothing to explain more. You can see on the board in the diagram. Right? You have 8 electrons. Okay. Which 2 statements about the covalent bond are correct? It can be formed between 2 metal atoms. Wrong. Then it's going to be a metallic bond, right? It's going to be a metallic bond. It can be formed between 2 non-metal atoms. Yes, that is possible, right? It is formed between transfer of electrons. Wrong. Transfer of electrons means ionic. Electron transfer of ionic. Sharing electrons, correct. Therefore, the answer is 2 and 4. Therefore, the answer is 2 and 4. Question number 15 could have been one of the most challenging questions in this paper, right? හොඳට අහගන්න මම explain කරනවා in detail, right? I told you the electric conductivity is the most important one when it comes to deciding what's the bond type. So if you look at W, it doesn't conduct under any conditions. When they say it doesn't conduct under any condition, you are getting 2 main examples. What are they? Simple molecular or giant covalent excluding graphite, right? If it doesn't conduct electricity, it must be either simple molecular or giant covalent excluding graphite and excluding acids. Excluding acids here and excluding graphite. So let's have a look at lead, W. Lead is a metal, so directly it's out. And it can be sulfur, non-metal. It is all right. That's fine, right? Now we'll go for X. It conducts only in aqueous solution. Did we learn something only in aqueous solutions? We can't remember exactly. We learned something like only in aqueous solutions, right? So it's kind of a tricky one. Therefore, I'm going to skip X and go to Y. Y says molten conducts when molten and when solid. That is a really important one. What are the substances can conduct electricity both in solid and molten form? Metals. Metals and graphite. Metals and graphite, but graphite, melting graphite is very hard. But they can conduct electricity in both what? Solid and molten form. In that argument, when I look at Y down, sodium chloride out, because sodium chloride can't do it in solid form. HCl is out, then I am isolating my answer C. So see, we didn't even look at X and Z. From W and Y we found the answer. That's the art of doing MCQs, right? Okay, but anyway, we can check the others as well. Conducts when molten and aqueous sodium chloride, it's agreed. And what is actually only conducting in aqueous, that simple molecular acids. They are simple molecular acids. 16. Which compound added water makes solution that's a good conductor of electricity? So something which can give you ions. Calcium carbonate insoluble. තාම ඕගොල්ලෝ සිලබස් එකේ ඉගෙනගෙන නැහැ. ඒකින්ද මේ question එක බැරි වුණාට worry වෙන්න එපා. Right? I'll put a star for the questions that it's out of your knowledge. so far. So then if you couldn't do it, don't worry about it. Copper is a metal, right? But you can use the strategy to learn it, right? Strategically, this is ionic, sodium hydroxide ionic, you know that, so it is the answer, even though you don't know the others. Right, a molecule of sulfuric acid has a structure formula of this 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bonds. There are 8 bonds, aren't they? How many electrons are involved forming all the covalent bonds? 1, 2, 3, 4, 5, 6, 7, 8 bonds are there. If there are 8 bonds, one bond is 2 electrons, will be 2 electrons. Therefore, it's going to be 16 electrons. You can see you have YZ2, right? And this is covalent. This is covalent, right? And this is covalent. So you can't choose a metal and non-metal, right? So this is out. And we have to take this. So this is one of the hardest questions you have, right? This is one of the hardest questions we have. And here you have like one pair of electrons shared. This is how you tackle this. One pair of electrons. One pair of electrons. And there are 7 outer shell electrons. Can you see? There are 7 outer shell electrons. 7 outer shell electrons. So that means Z has to be group 7. Z has to be group 7. Make answer D. So we'll verify that by looking at D, right? We'll verify that looking at the central atom. Why? Count the electrons 1, 2, 3, 4. Its own electrons 6. That means this is a group 6 element. Sulfur is a group 6 elements, right? So it is verified. The answer is D. You can see zinc and copper ions are there, right? So if it is only the copper ions, you know these cations can slide nicely over each other, right? So metals are malleable because the cation layers can slide. But when you have different size atoms, can they slide easily? Can they slide easily? No, therefore they are not malleable as usual. So that's why alloying make metals harder, right? But alloying lesson is a different lesson. This is our problem when we make tutorials from papers. We put questions, but when you deeply analyze it, the question is little out. But we still keep those questions because then you get the exposure for the areas that these are connected in future, right? Okay, you know then make a bonding lesson. Why is brass harder than pure copper? Zinc atoms are strong. No, covalent bonds strong. The zinc atoms prevent layers of atoms slipping over each other easily. That's the answer. Easy as that. Right? And the lamp, this lamp doesn't light because no current is going. Why not no current is going? This is KBr ionic. So the ions cannot move in solid forms, right? Ion cannot move in solid form. That's the answer, right? And distilled water is added to beaker, then the lamp lights. True, when aqueous form it light, the ions can move. Weak statement, electrons wrong. Never refer to the electrons in the ionic compounds in terms of electric conductivity. That was a rule. And the metal ions are free to move when the bromide melts. It's not only metal ions, right? Not only metal ions. It's both oppositely charged ions are free to move. So then metal ions, again that is wrong. So oppositely charged ions free to move in the solution. Thereby the answer is D. This is ionic. So you have to refer to the. Anyway, I'll just show you the connection between the charges of ions and the formula, right? You know, sodium is +1, Cl is -1, then it's going to be NaCl, right? And magnesium is +2. Cl is -1. You know that you need 2 chloride ions in order to have magnesium charge neutralized. Therefore, it's going to be MgCl2, right? So when you take lithium plus and nitride ion, suppose it's going to be N3 minus, right? Therefore, you need 3 Li atoms in order to cover the charge of nitrogen, right? Okay, so that part also you have to take into little consideration about the formula of ionic compounds. Anyway, you know because you join the ions because of the charge and the valency, right?